Right. Last class we were seeing point-to-point MPLS layer 2 VPN. This point-to-point MPLS layer 2 VPN is only between two sites. What if I have more sites? Then I have to create more virtual circuits, which is not a good approach. For example, if I have a hub with two sites, then from the hub I need to have two virtual circuits towards those two sites. So when I have one head office and two branch office, with what we learned in the previous class, I can only have with this, and I cannot have like this. If I want to have another VPN, sorry, if I want to have a layer 2 VPN, then I need to put another VPN, another virtual circuit. From this end to this end of P, we had one circuit for A to B to dock. If you want A to C, then you need another virtual circuit to negotiate. So let's say virtual circuit ID 100, virtual circuit ID 200, which means you need to maintain two separate sessions of VPN. CPU consuming method, not good. Then if you have 100 sites, will you have 100? Not good, not good at all. So what we need is a LAN service. This one is a wired service. Because it is a wired service, you need two wires, one to connect this, another to connect this. Now we are going to find a solution to have a LAN so that I can have only one multi-point VPN. Just one VPN, not two VPN, one VPN to talk to multiple remote sites, which is what we called as virtual private LAN service, VPLS. So virtual private LAN service can be deployed in Cisco IOS XE router environment as well as XR. But this configuration in this presentation is XE configuration. This commands are somewhat similar to iOS, but iOS routers don't support VPLS. Only iOS XE and iOS XR supports VPLS. XR configuration will be slightly different from iOS XE. So I have taken, for easy understanding, XE. Now, what is VPLS? Virtual Private LAN Service is a layer 2 VPN technology that allows multiple remote sites to be connected over a single shared service provider network. And now that service provider network will appear as a Ethernet switch or a single broadcast domain. Now, what is needed to achieve this? You need MPLS LDP. So with the help of MPLS LDP, we already did one lab, which is called virtual circuit or pseudo wire. What we had is a virtual circuit or a pseudo wire, which is a point-to-point wire. But this pseudo wire is a multi-point wire. It is multi-point. That's the big difference between the previous topic and this topic. So VPLS operates on layer 2 and extends an Ethernet LAN across. Very important word to be noted. Ethernet wire. Is it wire? No. Ethernet LAN, not within a building, but across geographically separated sites. That's VPLS, Virtual Private LAN Service. It's an extended Ethernet LAN across geographical separated sites. It eliminates a multiple point layer 2 Ethernet switch over MPLS network. So what is needed is MPLS LDP. It emulates, not eliminates. It emulates a switch, Ethernet switch. It emulates. But what is needed underlays a very good routing protocol like OSPF or ISS with MPLS LDP. So with the help of MPLS LDP, we will have a LSP label switch path, um, so that the VPN tunnel can be negotiated. Virtual LAN multi-point tunnels. Virtual LAN can be negotiated. So that's all. BGP is not a mandatory one. BGP is needed only if you do not want to say the sites. You want sites to be discovered dynamically. If not, you no need this. You will remember yesterday we did VPWS where we did not have BGP at all. Even for this VPLS, you no need BGP. BGP is an optional one. If you want to use BGP to do the three-way handshake and then establish an adjacency, then you need it. But when you go back and see our previous class, there is no need to discover BGP because there is no need to discover a neighbor because we were mentioning the neighbor's loopback address with which the neighbor adjacency need to be negotiated. So same way today we are also going to do that same static neighbor configuration. We are not going to use BGP. Using BGP with VPLS is too much. Um, BGP should be used in a proper way. Cannot be used for the silly things. BGP is a heavy protocol. It can be used in between the autonomous system because we will have a lot of policies. Just to negotiate and do discovery automatically, just to do signaling using BGP is not really uh, a right way, according to me. Instead, we can go and say the site reachable addresses manually so that multi-point VPNs can be negotiated. So what are all needed for VPLS? As I said, you need a very good IGP protocol. Secondly, you need LDP and MPLS. In Cisco, when you enable MPLS, LDP gets enabled, so you no need to keep it as a separate 2 points. But in most of the vendors, we have to enable MPLS and LDP separately. So I put it as a 2 separate points. Now, here is the topology which you need to keep in mind to understand the configuration. When you see the configuration, you will understand how this is going to work. It is same like what we learned in the previous class. The previous class it was point to point. This is also like a point to point, but you can also have multi-sites. This is also like from 192.168.1 to 192.168.2.0. We are trying to have a tunnel, but actually this should be one. IP address will be 1.1 here, 1.2 here. That's a mistake. So I can have another C here. I have an example with 3 sites also. This is just 2 sites. I saw this example in one place, so I just took it for easy understanding. I want to keep a small topology, so I took this topology. If you notice here, we have MPLS code. MPLS is running between these. Now, this dotted line is the layer 2 tunnel, so that you can have a layer 2 communication. All right, this is also one, this is also one. Same subnet. So you need a layer 2 switch. Now, let's see the configuration side. These are all the IP addresses. IP address is a mistake here. They have done a mistake. What you see here is we have OSPF running, and then we have MPLS running. Manually, you can give router ID. Here they are saying for MPLS to use as a router ID, use the loopback interface address, and the force command will force the router to use the loopback 0 address, even if router is using some other address. Now, this is the again just basic configuration with MPLS and OSPF. Now comes the VPLS configuration. You see, we are in PE1. PE1 is forming an X connect with PE2. This is not a new command for you. This is the same command what we did in the previous class. But the difference is this. In the previous class, we configured this right under the customer facing interface. You remember? We went to the interface here and we say no IP address, and then we say X connect, and then we say go and negotiate with this guy. Likewise, we went to this interface, we said X connect, go and negotiate with 1.1.1.1 encapsulation MPLS, we said. But for multi-point, you need to form a group. You need to have a switch actually. How do you create a switch? Now, how do you create a router? How do you create a router, virtual router? What is the name? VRF. But in switching, we call it as VFI. We need to create a virtual forwarding instance, a data plane, virtual forwarding instance. So what do we do is in the global configuration mode, we say we want to do an L2 VPN, and this is the name of the VFI. VFI and context, these are all commands, and this is the name that we give it. And then what we do is we say we want to use an ID 100. Even if you have 50 sites, for all the 50 sites on PE router, we should use the same number so that they will all form one 50 port Ethernet switch across the globe. And as I said, this is only if you want to have BGP. Here we don't need BGP because we are going to say who our remote site is. See, this is on PE2. We are giving the address of PE1, but it is not under the physical interface. It is under the VFI interface, virtual forwarding instance. We just gave the VPN ID as 100. We go under that interface and say xconnect blah blah 100 encapsulate MPLS. So only this command is same like what you did in the previous class. In the previous class, it was point to point, so we went straight to the interface. This time, we want multi-point. So you need a VFI first. And then we go to that VFI interface, which is ready to form tunnel with multiple points. And then we say X connect. In this example, we had only 2 sites. So we did this. But what if I have multi-sites? If you have multi-sites, this is what we will do. Same command. If you have multi-sites, say for example, I'm on PE1, but I want to form tunnel with PE2 and PE3. Nothing wrong, you can have many X connect statements if you have multiple sites. Did you understand this? See how easy it is. One VFI. One VFI can go and negotiate with multiple remote sites, but physical interface cannot do it. So this XConnect, when you do under a VFI, under a virtual forwarding instance, it is VPLS. If you do it under the physical interface, then it is VPWS. Is it easy? Now, these are all the verification commands you may use. Show MPLS LDP neighbor. This one, this is just to check MPLS neighborship. This is to check MPLS forwarding table. This is what for VPLS. Show L2 VPN VFI. It will show you with what all sites it is up. Or you can also say this command which we did yesterday, show X command all. And then you can try pinging your remote site, you will be able to ping. So in short, VPLS is a multi-site layer 2 VPN. For that, we need a VFI interface, and VFI interface configuration is like this. In the global mode, we say L2 VPN VFI context and give any name, VFI ID. And if you are running BGP between PE routers, then you may use this one. Otherwise, this command is not needed. We are not using BGP, we are using plain MPLS and LDP. So go under the interface virtual forwarding instant 100 and say these are the remote sites with which the negotiation should come. So PE1, which is 1.1.1.1, PE2, PE3, connected to customer edge 2, customer edge 3, customer edge 1, and we got a big internet site in between, in the middle, across the globe, across the geographical location. We are able to form a multi-point tunnel. Now we have a tunnel like this. Multi-point tunnel is created. Yeah. So it's very easy.